Section number 2 is entitled Measurements and Types of Angles. Let's talk about types of angles. A right angle, which measures 90 degrees, is called a right angle. An angle that measures 90 degrees is a right angle. If you are less than 90 degrees, less than 90 degrees. If you are an angle and you are less than 90 degrees, you are called an acute angle. It's less than 90. If you are more than 90, remember, with respect to that ray on the bottom, 90 would be right here. If you are anything more than 90, anything more, a little more, a lot more, it is more than 90. More than 90 degrees. This is called an obtuse angle. An angle cannot be more than 360. For example, up to here is 90. If you go along this line and you continue straight, that's 180. Up to here, that is 90, 180, 270 degrees. If you continue 90 more, you hit 360, which is the same as 0 degrees. A 0 degree angle, well, it wouldn't even go up 1 degree. That's 1 degree. 0 degrees, both lines would be on top of one another. This would not be here. That's a 0 degree angle. It didn't go up any. Both rays are on top of one another. Now, if you consider this very, very, very big angle, say 359 degrees, if you go a little bit more, you'll be back at 60 degrees, which looks exactly like 0 degrees. Okay. You have a right angle, which is 90 degrees. You have an acute angle, which is less than 90 degrees. And you have an obtuse angle, which is more than 90 degrees. Suppose you are given this acute angle, and you are told that the angle is called 3x plus 10 degrees. And you are asked, what are the constraints on that angle, and what is the constraint on x? Well, the constraint on the angle is it is in between 0 and 90 degrees. It can equal 0. Can it equal 90? The answer is no, because an acute angle by definition is less than 90. So that's the constraint on the angle. It's between 0 and 90. It's an acute angle, so it's between 0 and 90. I couldn't care less what it said here. I would put it here, right where I just boxed, and say it's between 0 and 90, and that it can equal 0. Because regardless of what we name the angle, it has, if it's an acute angle, it has to be between 0 and 90. Now, what's the constraint on the angle? Well, now we have 3 sides. Side 1, the box side in the middle, and the right side. Let's solve for x in the middle by first taking away 10. So the middle now is 3x. The left is negative 10, because 0 minus 10 is negative 10. And 90 minus 80, 90 minus 10 is 80. So now we have what 3x is in between. 3x is in between negative 10 and 80, and it can equal negative 10. But I don't want to know what 3x's are, I want to know what x is. If you have 3x and you divide by 3, you just get x. The constraint on x is it's between 10/3 and 80/3. And it can equal 10/3. Suppose you now have an obtuse angle. That's any angle that's between 90 and 360. It cannot equal 90, but it can and it cannot equal 360. Suppose we call the angle 2x minus 5. And all we know is it's obtuse. Well, if it's obtuse, it is in between 90 and 360. It can't equal 90 because then it wouldn't be obtuse. It would be a right angle. So I do not put an equal sign there. That sign that I just put is gone. I'm erasing it. It can't equal 360 because 360 is equivalent to 0. From 90 up to 360, including none of the endpoints, you can add 5, or should add 5 to all sides. That way the middle is now just 2x. 90 plus 5, 360 plus 5. Now we divide by 2 to get x alone. So we have to do that to all 3 sides. And x is in between 95 over 2, which if I'm not mistaken is 47.5, and 360, 5. I think I said it right, just didn't write it correctly. 360 plus 5 is 365. And when you divide that by 2, looks like you get 182.5 degrees. So x must be in between 47.5 degrees and 182.5. Now you can't start saying, but how can that be? If you're obtuse, how can x be 47.5? Very easily. I'm not calling the angle x. I'm calling it twice x minus 5. If you double this angle, you'll get 95. Take away 5, you'll get 90. You double this angle, you get 365. Take away 5, you get 360. And when you double the angle and you take away 5, you get 2x minus 5. But that's exactly what I said at the very beginning. 2x minus 5 is between 90 and 360. There are no constraints or constant constraints on x. It depends on what we're calling the angle. I can get x to be rather large. I can get x to be decimal values. It depends on whether you call the angle 2x minus 5 or x plus 3 all over 10,000. Do one more. This one's a bit easier. So I'm telling you, you have a right angle. That's given. You don't even have to draw it, nor did you have to draw any of the earlier ones. And I tell you, that's 3x plus 30. That's what I'm calling the right angle. Well, here there's no in between. There's no range for the angle. The angle is simply 90. So that's the constraint on 3x plus 30. It's 90. That's it. No arguments. It's done. It's 90. It's a right angle. Some number plus 30 is 90. That number is 60 degrees. 60 degrees plus 30 degrees is 90. You can do that. 3 times what is 60? 20. X must be 20 degrees. And that problem is done. The next part of this section is how to measure an angle. Well, there is something called a compass. A compass looks something like that. And on the compass, you're going to have a little hole there. That's the center. And if you happen to go all the way to the left, you'll see 0. And straight above, you'll see 90. And here you would see 45, and say 15, and 30, and 60, and 75, and 135, 105, 120, 180, 150, 165. You would see those numbers. In fact, your calculator might highlight other numbers. But in any case, you have numbers like that, 0 through 180. You also are going to have most are compasses, protractor. You're going to have another set of numbers. And depending upon how your protractor is built, it might be in different colors, what have you. This will be 180, 165, or 150, 135, 120, 105, well, I don't know if I'll say 90 twice, but then 75 and 60 and 45 and 30 and 15 and 0. Okay. Now, if you have an angle, what you need to do is concentrate on this line. Put AB along that line I just drew on the compass, but in addition, put A right where the circle is. Right where that circle is, you put the vertex. That's key. You put the vertex. This point right there goes on that circle. And AB should be along that line. So when you move the compass to the angle, or to make my life easier, if I move the angle to the compass, you put A right here, it goes to the right, and it opens up to some number, and it turns out that number is exactly 45. Now, why is there also 135? 45 or 135? And the reason is straightforward. If you have an angle like this angle right here, and this is A, well, you put A right on that circle. But this time, the side goes to the left. So you put A, the angle right on that circle, or you move the protractor down to the angle, put that circle, which is now a dot, right on A. Make sure that this side lies against this line, and that other side is going to go like this. Now, since this angle is, that's 90 right there, since it's more than 90, we read a larger number. This angle here would be 135 degrees. If you take the protractor and you have another angle, move the protractor. Suppose you have this angle here. Well, what you do is you move the protractor, so this circle is right here, and you level it with this line. So here is your compass. protractor. If I say protractor, don't mind me. Now, what you need, so now over here you're going to have two numbers. And since we want to measure this angle, which is more than 90, make sure you read the number that's more than 90. Now, it might be that you have 100 here, and you have 110 there. Well, you're going to have some ticks. Let me just lower this a little bit. Between the 100 and the 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you just have to count. It looks like that's 105. Because 101 is right there. 102 is right there. 103 is right there. So the next tick is 104. It's 104 degrees. The key thing again is to make sure that you put the protractor on the angle correctly. If you have an angle that goes that way, not a big deal. Put the circle of the compass there and rotate the compass so that that line that goes through the center is lying right on top of that side of the angle. You could have done it another way. I'll show you the other way in a moment. And your compass, your protractor goes like this. Now, since we're measuring this angle, it's less than 90. And basically, your angle at least has to go up to, if not beyond, the protractor. Now, if it turns out that your protractor has 40 here and 45 there, so let's make that a 5. Well, let's even make it 50. Then how many ticks are there? Well, we have 40, 41, 42 is where we are, let's make believe. 43, 44, 45, 46, 47, 48, 49, 50. So that will be 42. 42 degrees. And I did say we could have done this in one of two ways. And try very hard to draw the same exact angle. There it is. When you put the circle, actually it's a hole, but when you put the circle or hole of your protractor at the vertex, you don't have to line it up with this side, you can line it up with the other side. That is, that line on your protractor should be along one of those two sides that make up the angle. Okay, so I drew it a little bit too long. Alright, so there it is. And since the original angle was this one, which is less than 90, I'm going to read off the smaller of the two numbers that happen to be right here. And just like before, you're going to have, say, 40 right here and 50 there. You have 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and then 50. Now this other number is going to be, in other words, if we really wanted to measure that angle, that is, what if the initial angle went from here to here? What if that was the initial angle? So we want to know this angle right here. And that's more than 90. Well, in addition to saying 50 right here, it's also going to say 130. In addition to saying 40 here, it's going to say 140. Notice they always add up to 180. 50 and 130, and 40 and 140. Well, in any case, this mark here is 130, 131, 32, 133, 134, 135, 136, 137, 138. Of course, you could have started at 140 and say 139, 138. So the angle does not have to have one side that's horizontal. Rotate the paper if you only like to measure angles where one side is horizontal. If you have an angle like this, rotate your paper and then it will be horizontal, and then measure it. Okay, it doesn't matter. Okay, this finishes the section on measuring angles and types of angles.